All right, kids. Here's your quiz question that I was telling you about. So we're going to calculate work and power for me doing squats. Okay, so let's remember first that work is force times distance and that power is work divided by time. Okay, now we need to figure out what my force is, and I'm going to do squats two ways. I'm going to do air squats, so with no weight, and then I'm going to add weight. So we need to figure out what my force is both times. So let's calculate that first. Okay, so my mass in kilograms is 80 kilograms. Okay, so my mass in kilograms is 80 kilograms. All right, Nate, you have your phone?
Yep.
Get your calculator on. Okay, so if my mass in kilograms is 80 kilograms, okay, we need to figure out what my force is. Now remember, my force is my weight. Okay, so remember that force equals, here actually, will you hold this while I'm writing? Okay, so remember that my force, okay, is equal to my mass times acceleration due to gravity. So that's going to be equal to 80 times 9.8 meters per second squared. So my force,
784.
my force in newtons is 784 newtons. Okay, now for a squat, okay, for a squat, you actually only use 65% of body weight for a squat. So we need to multiply 784 by 0.65.
509.6.
Okay, so let's round that up and let's say 510 newtons. Okay, so my force for the air squats is going to be 510 newtons. All right, now for the second set of squats, so with my kettlebell, okay, so let's take a look at the kettlebell. It's on the floor down here and zoom in real close. And do you see? Okay, so it says it's 24 kilograms. Okay, so let's come back over here. Okay, now I'm going to flip this over. Okay, so again, so force is mass times acceleration due to gravity. So our mass is going to be, okay, so remember that my mass is 80 kilograms plus 24, okay, from the kettlebell, okay, times acceleration due to gravity, which is 9.8. So that's 104 kilograms times 9.8.
1019.2.
So we'll just say 1019. Okay, and that's newtons. Okay, and then for a squat, okay, because remember the squat is 65% of your body weight. So for the squat, 1019 times 0.65.
This is 662.35.
Okay, so we'll say 662 newtons, okay? Okay, so obviously you can watch this video as many times as you need to. Okay, 662 newtons, okay? All right, now, the next thing that we're gonna have to do is we have to figure out what the distance is, okay? So the distance is gonna be how far I go down on a squat. So to do this, okay, so I'm gonna, against the mirror here, I'm gonna kind of set this up. Let's see, I'm gonna put my finger right here. Okay, so we'll make it easy. Actually, it doesn't really matter. So I'm at 38, okay? I'm gonna go down to right about here. So that is about 18. So I went down, so 20 inches. Okay, so now get your calculator back out. So, okay, now we need to convert inches into meters. Okay, so inches to meters is, we're going to multiply the inches, which was 20, times, let's see, first go times 2.54, because that's centimeters.
50.8.
Okay, so that's 50.8 centimeters. Okay, and then divide that by, let's see, times 1 meter over 100 centimeters, and that's going to be, so that's going to be 0. Okay, so let's round that up and let's say 0.51 meters. Okay, so our distance is going to be 0.51 meters. Okay, so 0.51 meters. All right, now here's the thing. Okay, and I'll flip a page over. Okay, and I'll write all this again. All right, so I'm going to do squats for 30 seconds. And we're going to see how much power I produce and how much work I do first, and then how much power I produce from that, okay? So again, I'll do the air squats first, and I'm gonna start right now. I'm gonna do this for 30 seconds. I'm trying to go the same depth every time. 20, 1, 2, 4, 25. Okay, 25 in 30 seconds. All right. So let's see, we did. So we did 25. Okay, hang on, no, don't do that. Okay, so now we're going to do the kettlebell. Give me just a second here. Okay. Wow. Okay. So, okay. Let's go ahead and stop the video.